Hi, my name is Ben, and today I'm going to present you 4 projects that you can do in order to improve your skills in deep learning. I will sort them from easy to a little bit more complicated, and I'm going to recommend you to do them in PyTorch because recently there's been a shift from researchers transitioning from TensorFlow to PyTorch. So do them in PyTorch if you're enrolled in a bachelor or master studies. So the first task is to build an image classifier for the Mnist dataset. In case you don't know the Mnist dataset, it basically is the hello world of deep learning. So the task is to recognize handwritten digits from images. For example, you have this image and you want to predict the number that you can see. You should be able to solve this task using convolutional neural networks. In case you don't know how to train such networks, you might need more knowledge before going on with such projects. I'm going to link the Mnist dataset in the description, and in case you don't have any GPU to train on, you can use Google Colab up to 12 hours per session for free. Every link is down in the description. So the second project is actually a little bit more complicated. It is not about classification but regression. The task is to implement a model that can predict the price of a house using the housing price dataset from Kaggle. By the way, Kaggle is an awesome website if you're looking for a large variety of datasets. So you will not only be able to learn how to implement a regression model using deep neural networks, but also stuff like feature pre-processing. For example, you would need to implement a one-hot encoding for categorical features. An example for such a categorical feature would be, for example, the type of a house. Either that the house is an apartment or it is a mansion. So the third project is about implementing your own deep learning framework from scratch. So no PyTorch, no TensorFlow. I know this sounds very complicated, but it's still quite easy. So for each different layer type that you want to implement, you just need to create one class. For example, for a convolutional layer, you create the following class. Then you save your metadata, for example, in and out channels, implement your forward pass, and also implement your backward pass. And then you already have implemented one layer for a deep learning network. So if you don't feel comfortable yet with doing so, I'm also planning on doing a tutorial series on how to implement the layers from scratch. This project will give you much deeper understanding of the concepts from each individual layer, but also make you more comfortable with the matrix multiplication, or let's say matrix arithmetics that are often used in machine learning. So the last project is about implementing a fake image generator using Gans. So we again use the Mnist dataset, and what we want to do is create fake images that resemble images from the Mnist dataset. Generative adversarial networks are quite handy for this project. So they consist of 2 neural networks, one generative network and one discriminative network. The generative network creates the fake images, and the discriminative network tries to distinguish the fake images from the real images. It is quite difficult to train Gans because the loss for the generative network actually depends on the prediction of the discriminative network. So if the discriminator can actually distinguish the real and fake images, then this increases the loss for the generator, which should then try to create more images that resemble the Mnist dataset. If you want to have an example implementation, if you're not too comfortable on coding this on your own, you can check out the PyTorch implementation, which I'm going to link in the description. So thank you very much for watching. If the video was helpful, make sure to like and subscribe, otherwise hit the dislike button. So see you next time, bye.